a space shit. I'm sure an astronaut has made that joke before. All right,
Yeah.
and we're rolling.
Well, hey guys, this is Thomas's Torture Time. You're here with Thomas Panner, Captain Jack, Coda, and Meister P, all my good friends. We're here tonight because we're continuing our series. Let's see, we started with the philosophy. Well, at least here recently, since I've been streaming on YouTube, we started with the philosophy of science. There will be episodes that will be posted um, online later from our previous, what do you want to call it, platform called Callin. I have some shows where we did, I haven't really told a lot of people this because I have so many of them backed up, but we will be getting those out there. My epistemology series, my linguistic series, my logic series, but we will get to that. Anyway, today, science. So we talked a lot about last time. We talked about the history mostly, right, Perry? Is that what we went over?
Yep, we started. I don't know. I guess with the pre-Socratics, and then we got up
Mm-hmm.
to. I don't know. I think we kind of stopped right before Einstein ish.
Well, I remember us covering the 21st century science
Okay.
and technology. I mean, I guess we could cover that more because that would. But I think just a quick recap. The Human Genome Project was completed in 2003. The inertial containment fusion was in what 2022 last year. Seeing Sagittarius A through an event horizon telescope looking at the center of our galaxy, a black hole's accretion disk. We actually saw it, so we actually have a physical picture of it now. Uh, Discovering the Higgs boson in 2013, um, discovering gravitational waves in 2015, which was predicted by Einstein in general relativity, but the first time we observed them was in 2015, and it was a crazy way we had to do it. They had to line up two huge lasers that were like a mile long.
So far away from each other. Yeah.
Yeah, and like the movements on that laser on a piece of glass or something like that was measured in like way smaller than nanometers. I mean, I don't even know picometers. I don't even know where to go. I don't, extraordinarily small amounts of movements, and that's the gravitational waves from like the background of the universe. But those are all some big leaps and bounds for us just within the first 23 years of the 21st century. So the mapping of the human genome was a big thing. That was a really big thing. And the head of it, Francis Collins, is a Christian, and he said the DNA evidence alone would show us common ancestry with apes. We are going to get into evolutionary biology, by the way, too. So we will be speaking a bit about that. Maybe we'll get on specific sciences at some point, but I don't want to spend too much time in one place because I think Perry has convinced me that we need to cover this in a more general way instead of getting ultra specific on everything.
Yeah, and I think that it'll come up at some point later
Yeah,
down the road as well, which
yeah,
will, I think it'll be nice and it'll flow nicely
yeah,
more that way.
I agree. So let's quickly, we're going to talk about the branches tonight, okay? So modern science is commonly divided. By the way, all this stuff I'm getting from Wikipedia and a textbook that I found on lumenlearning.com. You can go there and find all these textbooks. They have introduction to psychology. They have introduction to life science. They've got all this stuff, and I'm using them and I'm using Wikipedia for us to study off of because I think that's going to be, on the science page on Wikipedia. I haven't seen any unsourced articles or where it says it needs more sources. It looks like it's pretty well fleshed out. So I'm going to trust it 95%, to give me the correct information. And I think we should, at least by today's standards. If you were talking about like 15 years ago, Wikipedia, maybe not, but it's not like that anymore. It's very, very
That's
reputable.
about right. I'd say 95%. I'd say
Yeah.
one out of 20 times you'll find
Yeah.
something a bit iffy. And
Yeah.
yeah,
And they usually state that it's not well formed or it's not well sourced or something like that, right? So, the three major branches of science are natural science, social science, and formal science. Okay? Each of these branches comprises various specialized yet overlapping scientific disciplines that often possess their own nomenclature, their own design structure, and expertise. So, both natural and social sciences are empirical sciences, as their knowledge is based on empirical observations and is capable of being tested for its validity by other researchers, independent verification, working under the same conditions. Okay? So we're working with empirical observations, empirical sciences. So, natural science. This is the most fundamental of all sciences. Okay, physics, right? Natural science is the study of the physical world. It can be divided into two main branches: life science, which is just in general. Let's pull this up. My hands are fucking shaking. My medication.
So like
Okay. So life
biology
science is
or
anything that is biological,
yeah.
right? Anything that is within biology. If this freaking thing will open up. Oh my God. Okay. It comprises the branches of science that involve the study of life, such as microorganisms, plants, human beings, everything within the phylogenetic tree. So, life sciences and physical sciences are natural sciences. These two branches may be further divided into more specialized disciplines. For example, physical science can be subdivided into physics, chemistry, astronomy, astrophysics, and earth science. Most natural science is the successor to the natural philosophy that began in ancient Greece. Okay, so we've explained that a few times. Do you have a better way of explaining how everything became science, Perry, or anybody here that wants to explain it?
Ooh, how
How it
did
used to be called natural philosophy and how that changed? Because I don't mind explaining it. I just thought somebody else had a take on it.
ooh to to do it briefly, the same way that math was magic back in the ancient times, things started to get a bit more demystified.
Hmm.
I would say, especially when we're focusing in the natural sciences on
Hmm.
empiricism, the phenomena of everything. Um,
Yeah.
the de-religiousifying was a big one,
The
even though
de-religification.
yeah, even though much of it came from Christianity, right?
I
Supposedly
mean,
in many
they had all the
aspects. So,
schools. They had all the
um,
schools, and so they called it natural philosophy until basically the Renaissance. Everything it was natural philosophy, and then it just branched out. They got more and more specific. They accepted a physicalist, reductionist, empirical stance on things, and it eventually just became these sciences. Natural philosophy, the study of philosophy, morphed into science with all it birthed everything. And I guess I could give a quick explanation of natural philosophy. It was the philosophical study of physics throughout most of time. You know, um, Galileo, Descartes, Bacon, Newton, Leibniz, they debated the benefits of using approaches which were more mathematical and more experimental in a methodical way. Still, philosophical perspectives and presuppositions, often overlooked, remain necessary in natural science. We have to have these presuppositions that we've talked about on previous episodes with the philosophy of science, naturalisms or materialisms and physicalisms presuppositions. So we won't go over that again. But systematic data collection, including discovery science, succeeded natural history, which emerged in the 16th century by describing and classifying plants, animals, minerals, and so on. Today, natural history suggests observational descriptions aimed at popular audiences. So that's interesting that systematic data collection, including discovery science, patterns, correlations, and form of other. No, that's the way that they used to look at it. We're going to move on. So let's talk about natural science. We're not even going to move on to social sciences or formal sciences just yet. And there's also applied sciences, but we won't go to that. Let's get real deep on natural science. Okay. So does anybody have anything to input before I go on a little bit of reading or
nope,
what?
I think I answered my own question with what science is not empirical, and that's kind of like the formal stuff that we won't get into just yet. More
Yeah,
so,
we can talk about it. I can go
yeah.
back and here let's read a quick paragraph on it because I think that's a good idea.
Okay.
Before we I think that's a good idea. Okay, so we know what social sciences are, but we will explain this. So, formal science is the study of formal systems, right? Linguistics is a formal system, logic is a formal system. These are formal systems. Um, a formal system is an abstract structure used for inferring theorems from axioms, right? An axiomatic structured system. These are all abstractions. You can do that with anything. You can make a system out of anything abstractly. So it includes mathematics, systems theory, theoretical computer science, theoretical mathematics. The formal sciences share similarities with the other two branches by relying on objective, careful, and systematic study of an area of knowledge. They are, however, different from the empirical sciences as they rely exclusively on deductive reasoning. So, mathematics and theoretical computer science, these are all deductive systems that we have instantiated through our construction of their languages. Um, the formal sciences are therefore technically a priori disciplines, and because of this, there is no disagreement on whether they constitute a science. Nevertheless, the formal sciences play an important role in empirical sciences. Calculus, for example, was initially invented to understand motion in physics by Newton and Leibniz. Natural and social sciences that rely heavily on mathematical applications include many applied sciences: chemistry, biology, economics, even finance, all that kind of stuff. So, mathematics, without getting too much into the philosophy of mathematics, it is a deductive formal system where the premises necessarily lead to the conclusion every time, because they are all an agreed upon standard. They are a deductive standard. They are describing what is happening in physics. So it's a descriptive language, but it's completely deductive. We agreed on what was the equal sign and what addition was and what the numbers were, but it is a deductive logical system. Does anybody want to say anything about that?
Mm-mm.
Okay. All right. So that's a formal science. What other formal science? We use calculus. What else? What other formal sciences do we use in applied science? What can we think of?
Anything with logic, coding.
Yeah, engineering,
Um,
right? I mean,
yeah.
engineering is basically all calculus. I
I mean,
mean, or a lot of calculus.
any tautology, perhaps even in linguistics, maybe. I don't know.
Mm-hmm.
Um,
No, that's true.
anything deductive, right? If it's a priori
Anything,
and deductive.
any
So
deductive formal system, yes.
yeah.
Right. Yeah. Perhaps even like the language that scientists use to like communicate with each other and to gather observations could be seen as like a formal system.
Mm-hmm.
Yes, and it should be seen as a formal system, and that would be the scientific methodology that best fits the situation that we're attempting to experiment with and observe and get data from. So
Yeah.
now that we've said that, let's jump to natural sciences, and this is where we're going to get into the nitty gritty. We're going to start talking about some actual fields, and we're going to talk about them. Okay, so we know that it's life science and physical science. All right. Let's see. And within these sciences are academic disciplines. These are major categories. These are things like earth science, physical science. Well, let's get into it, okay? Branches of natural science. First, we have physical science. This is the branch of natural science that studies non living systems, in contrast to biological sciences. It, in turn, has many branches, each referred to as a physical science, together called the physical sciences. However, the term physical creates an unintended, somewhat arbitrary distinction, since many branches of physical science also study biological phenomena, including organic chemistry. So let's start with, because it's basically in alphabetical order here. Astronomy. Astronomy studies the universe beyond Earth. It's like studying the map, whereas astrophysics is studying how shit works in the map, right? It's about its cosmology, astronomy, and astrophysics all are intertwined disciplines, and they deal with the formation and development and the evolution, physics, chemistry, meteorology, and motion of celestial objects. So anything that originates outside the atmosphere of Earth is astronomy's calling. And there's plenty of different things in there, like astrobiology. Anybody ever heard of astrobiology?
Mm, is that just the life sciences for astronauts out in space?
Close. The study of evolution, distribution, and future of life in the universe.
Okay.
Let's go to it real quick. Let's look at it. So, astrobiology is a scientific field within the life and environmental sciences that studies the origins, early evolution, distribution, and future of life in the universe by investigating its deterministic conditions and contingent events. There's some interesting metaphysics for you. As a discipline, astrobiology is founded on the premise that life may exist beyond Earth. I wasn't even really familiar with astrobiology until earlier today. So, obviously they're going to study, hang on one second, my voice. Research in astrobiology comprises three main areas: the study of habitable planets and beyond, the search for planetary biosignatures of past or present extraterrestrial life, and the study of the origin and early evolution of life on Earth. So it's going to deal with things like abiogenesis. Does abiogenesis happen on other planets the same way everywhere? Like, if abiogenesis happened on Earth, then that means somewhere in Alpha Centauri, if abiogenesis happened there, then they'd eventually get humans too. What do you think about that, guys?
I think it's something that we shouldn't give too much government funding to, but perhaps somewhat of a significant amount. I get the
Maybe a
whole
few million.
yeah. I mean, I get the whole habitable planets
Yeah.
thing and whatnot. That makes somewhat sense. So
Do you think that abiogenesis on another planet would result in anything other than humans?
oh yeah, I mean that's possible.
You think so?
Wait, say that
Uh,
again. That abiogenesis would result in something other than
Right. Let's
humans.
say we had abiogenesis and it eventually resulted in humans on Earth. What if abiogenesis happened on another, let's say, Class M
Oh,
Goldilocks zone planet? Do you think that would eventually bear fruit in terms of humanity, or would it form another? Does
yeah,
abiogenesis not necessarily lead to humanity? Maybe it leads to a dinosaur
correct.
species,
The
right?
latter that you just said. It doesn't necessitate humans. I don't think it
You
would.
don't think it necessitates
No,
humans? Okay.
no.
I think there might be other humans out
You're
there. I
you're
think
muted,
there.
Jack. By the way, you're muted.
Oh, yeah, you're muted, Jack.
Yeah, you're still muted. I'll be right back. By the way.
Go ahead. Jack, you there? Oh my God, Jack! No,
Oh no,
you're
Jack.
muted, sir. What is
He doesn't know
wrong?
we can't hear him.
Wait, there you go. Was that it? Try it. Nope.
Honestly, no matter who you are, you can't deny he's speaking facts right now.
I don't know why it's not working. We might be able to, when Perry gets back, we can probably send you another link, maybe?
Nice.
Damn, what's up, Scott? You watching us? Big Scotty boy?
Hey,
My big
Scott.
Scott.
Hey, Mega.
You fucked up, didn't you?
And then I could talk. So yeah, no, I really wanted to agree. It doesn't seem like there's no reason to, at least from there's no reason physically or like from any way that I can tell from physics that abiogenesis leads to humanity in any specific way.
Who's?
Yeah, not necessarily, but I would like to think.
Knows that.
Go ahead. No,
Who
it's
even
fine.
knows that abiogenesis is going to ultimately end up with humans on Earth? Like, we could still die. Like,
That's true. You're right.
No, 100%.
You're right. But does the
talking more
process? But does the process itself eventually lead to humans, or is it a process that could lead to dinosaur people, or some kind of other type of being that would come from I'm thinking of things that could live in the Goldilocks zone, though. Of course, I'm not thinking of things that might be silicone based life or some other kind of life out there that we don't know about. I'm just thinking of planets that have an abiogenesis event there. What comes of that?
Unless for some reason the hominid type class in this universal game has some like better chance of receiving a higher intellect brain or a higher capacity brain in general, I don't think that there's any reason why it would lead anyway to specifically humanity be like Homo sapien. Like there's so many other options for things to just as well like have just as intelligent of a thought process, just as great of the cognitive function, except just it didn't end up being a hominid type species, or like it didn't end up being a Homo sapien. It's very, it'd be pretty hard pressed to try and say that it would all fit this mold across every standard of like livable planet, because just because livable to us doesn't necessarily mean life.
That's what I was saying.
Yeah,
that's exactly what I was saying. So yeah,
there could be a being on Jupiter right now living in that hostile environment, but it's able to adapt to that, and it went through some sort of
and we can't
abiogenesis.
sense it with our sensors,
Right. I mean, humans would get fucked up, but there could be some plasmic type of being
So
It's like a it's like a conscious formation of like
yeah.
interwoven like
It
molecules
could be.
on like
Yeah,
a
why
level
not?
that we can't observe.
Anything,
man,
anything
we're
is
just like
metaphorically possible.
I was about to say we're just like a lot more of a fleshy version of that. I mean,
Yeah,
Pretty much, yeah. Just a bunch of complex atoms
at
roaming
a
around,
different
but
scale.
Yep.
a lot of carbon. We need a lot of carbon, personally,
Yep.
right?
I'm excited to see. I really want to see if we get another. If we can understand like a different species from a different like planet exists out there. I think
Would
it'd be
we-
really cool if it was silicone instead.
Well,
of,
that would be
That's
cool,
what I
but
was
would we assume, Jack? Would we assume that if a planet is in the Goldilocks zone like we are, that it would be carbon based? Would you think that or not?
Not necessarily. I think that carbon-based life in the Goldilocks zone that we understand as the Goldilocks zone would probably be more likely. But I
Hmm.
think that there exists a Goldilocks zone that's slightly different from ours that would benefit silicon life like entirely, and it would.
Some scientists
much-
argue against silicate life. They say it's not possible, but I
I
don't
mean,
know.
it's the only reason why, at least from my understanding of the only reason why they think it's possible is because silicon is almost as diverse and or as diverse as its capabilities of bonding to things as carbon is.
I
And that's-
wonder, Jack, if that's because on the periodic table of elements, carbon is number 6, and
Yes.
right below it is silicon.
Mhm.
And I wonder if that could be a reason why it's able to adapt just as well and bind with a bunch of different things like carbon.
It would
Or
be
if it's just a
if you're a
coincidence.
sister or a cousin molecule to something that that capable of binding, then wait.
I just wonder if the placement on the periodic table of elements, silicon is right below carbon, and it could just be a coincidence, but I wonder if that also gives us some, symbolism as to it being
Some
able to,
insight, maybe.
some insight as to it being able to bind to a bunch of different things, but could just be a coincidence.
I mean, it could be just a coincidence. Yeah.
Yeah.
What do they call that? A synchronicity? Yeah.
Yeah.
Yeah. So astrobiology, I kind of tend to agree with Perry. Shouldn't put too much money into that, right?
Yeah. I mean, let's maybe fix some of the other issues before we think about.
Yeah.
Was it?
I don't know.
No. Hold on a second. I just want to address Scott real fast. Scott, I just looked it up on the periodic table of elements. Silicon is number 14. It's right below.
It's right below carbon. Yeah. Carbon
Scott,
is
you
6,
shut the hell up.
silicon is
I just
13.
wanted to adjust it real quick. 100%. Look that up. Figure that out real fast.
Selenium, Scott says. Let's see, where's selenium?
I
You
just-
know, you could just send
It's
Scott a
34.
link and have him come up here, but he probably won't do it because he's a dirty bastard.
Ooh!
Yeah,
Selenium is number 34, and it's
Yeah.
1, 2, 3, 4 over and 2 down from what he's talking about.
Anyway,
I had to address that because it's bugging me. I didn't know if he was right or not.
I sent you a link,
Scott, if you want to join us, come in and talk with us, man, brother.
But let's see what.
Well, is it? I just wanted to ask:
Yeah.
do you think that is the Drake equation used in this at all, or is that just hokey pokey?
Well, yeah, that's going to be something that is considered. The only problem with the Drake equation is we don't have any of the variables. We don't.
Right.
That's why the number could be 10 or 10 trillion.
Right.
We don't know the variables. So, like, it. Just explain the Drake equation.
It depends. So it's n equals, was it r asterisk times f to the p, or not f to the p, f to f with a p exponent times n with an e exponent times fi. All that really breaks down to is n equals the number of civilizations which humans could communicate.
Yes.
Was it that one is an unknown variable for fucking sure.
Yep.
R asterisk means the rate of star formation. We can get that one. We can get the rate of star formation. Is it a fraction of stars that have planets? We can't look at the entire sky, but we can do an extrapolation based on the ones that we see. So hopefully that's at least average, and it'll do us a decent number. Is it a mean number of planets that could support life per star? But again,
We don't know that.
Well, it's the same exact thing. We can only hope that we can see like the Goldilocks zone for all of these.
I mean, you could assume that in that Drake equation with that variable that you're talking about, we could assume that every star has a planet that's viable.
You could I would no. I was you could say fractional stars that have planets, but
what it really should say, at least for my money, maybe it doesn't. But a fraction of stars that have planets in the Goldilocks zone, like at least for our Goldilocks zone.
Is it for carbon life? Is it then the mean number of planets that could support life per stars with planets would change to the Goldilocks zone? Hello.
We can hear
Now
you. Hang on. What? Slow
Yeah,
down,
we
Jack.
can
1
hear you.
second. We can hear you, Scott. But
Yep, you're in.
I was
Scott, let
I was
Jack finish
talking to
real
him.
quick.
My bad.
It's all good.
Go ahead.
Is it is it
point out that like the Goldilocks zone has nothing to do with like carbon. Silicon is not the same thing as psyllium. The reason carbon is the basis for like all compounds on Earth is because carbon has a negative polarization, right? So like most atoms have a positive polarization. Carbon has a negative. So what it allows is it allows a lot of things to combine with carbon,
Oh,
right?
I agree with you, Scott. Hey, Scott, can you let Jack finish this real quick? He was going through the Drake equation.
Oh,
for our
sorry.
audience. No, it's just for our audience. Go ahead, Jack.
1 second? Yeah, no, is it let's go back over to the Drake.
I have the Drake
Okay,
equation
so-
up here, Jack.
Yeah, the fraction of life supporting planets that develop life. That is an unknown variable, but just because things are in the Goldilocks zone does not necessitate that we can understand that it will develop life. Just because it's there does not mean it will do that. Was it then we get to the fraction of planets. Was it a F to the I or F to the F? You know, it's
F
not
to the X or whatever? Yeah, sure.
There's a few F's in here.
It's an F to the fraction of planets with life, where life develops intelligence. That's an unknown variable. Even if they develop life, we have no idea if they developed intelligence.
We have one so far. We have
Yeah,
one.
fraction of intelligent civilizations that develop communication. Also, like only us as far as we know. So that's not a good variable. And then the length of time that civilizations can communicate. Now, while that's a variable that we could pretend we can understand, the interesting part about this is that it's an estimation of the time before like a civilization collapse where they can't communicate anymore, and the ability for them to communicate technologically. So between the technological ability to communicate radio waves and the collapse of that civilization is what L would be.
Maybe they are communicating, but it's not with radio waves. So we also, I mean, that's also.
If there's another way to communicate long distances like that, then yeah, we're probably missing it.
Yeah.
Mm-hmm.
Like if
What did you think, Scott? Go ahead.
Oh, sorry, I just didn't hit mute. I'm sorry.
No, go ahead. What did you have to say? We got Don with us here too. All right.
I was just talking about like
welcome.
what makes carbon the basis of organic molecules. Why do we look at organic chemistry as being a carbon-based thing? It has to do with the fundamental nature of carbon. Silicon is not the same. Like Jack, I think you meant to say selenium. Selenium has like the basic same.
Captain Jack's saying no, Scott. He's saying no.
Yep. Oh
We
no,
can't
no.
hear you, Jack, for some reason.
Carbon versus selenium.
Okay.
Let's see here. Da-da-da-da.
Everybody give a hand up to our Perry. He's doing a good job putting all this shit up here for us.
Whoa, putting together a PowerPoint.
Yeah. All right. So where's it at? Show us.
So carbon versus selenium. Carbon has like, I mean, the difference is like we're talking about like valent and covalent bonds, right? If you understand what I'm talking about versus the positive.
Do you want to explain that for the audience?
So a covalent bond is the basic magnetational force of an atom, right? So like you have an electron, a neutron, and a proton, right? The electron's negative, the proton's positive, the neutron's neutral. Depending on each atom, it's going to have more numbers of electrons versus neutrons, right? So this is what's going to
Yeah, protons and neutrons are what bind in the nuclei of atoms, right?
No. It's just what the atom is made of. What they bind into is molecules, and then those molecules become things, right? And so carbon, selenium, silicon, these are atoms, but those are all just like the base of some sort of compound that it's going to come.
Yeah. No, I was agreeing with you, but I was just referencing.
So can I bring up what I mean by this?
Yeah, go ahead.
When I say life and something. So Oh, is it? No worries. It's fine. I'll just leave it there. Is it, it's a Smithsonian. It's a Smithsonian magazine.com. Is it fucking? Is it
I was just going to say real quick,
Go
we should probably, just for the hell of it, so people can understand this, would you look up real quick, Perry, the strong and weak nuclear force, and go to images, and I'll show you the one that's the best.
All right. So is it essentially? Is it
Yeah, go to images.
silicon-based life forms are like theoretically capable of happening, and also
That's
physically capable of happening. But was it? But it really wouldn't be. It really wouldn't be the same type of life that we're used to here. It would be life, and it would be life in a way that we are not used to. But it would more like it couldn't form anything very solid. It would be kind of like a clump or a blob.
Hang on, Jack, 1 second. That dark one in the center, Perry, go down a little bit. No, buddy. A little bit further down the page. Okay, right there, those two. Yeah. So that's what the strong nuclear force does. There's another one that's a little bit further down the page, and it'll show weak nuclear force. There you go. So both of those are in the formations of the nuclei of atoms. We have to have both of those forces in order to create protons and neutrons that both they force each other apart, and then they suck each other together. So if we didn't have the strong and weak nuclear force, we couldn't have nuclei of atoms. So just thought I'd point that out for everybody.
So essentially, it wouldn't be able to have like a very strict, strong form like carbon-based life would have. It would be very blobby. It would be very. It could be like slightly like rough or hard, but it wouldn't. They might not even be able to reproduce. Okay. And the intelligence level of these things would be lower than humans for sure. However, the likelihood of these things existing is as likely as any life existing across the fucking universe.
Sure. Don, do you have a take on the Drake equation?
First of all, I don't even know what the Drake equation is.
So it basically is a big equation that says here, Carl Sagan went over it, and a lot of other people have too. It's a big equation that says how many planets can there be that have life? How many planets? Here, Perry's about to bring it up again.
Yeah. I just went through it a second ago.
Yeah. If you can see that, can you see that, Don?
Yeah, I can see it.
Yeah, give a quick read on that.
Yeah, a few of these. A few of these values are actually a good portion of these values. We don't have the ability to actually have the variable for. A few of them we do, and a few of them we could extrapolate, but a lot of them we don't actually have the ability to create the variable in our.
There's no number to go back to. Yeah. It's like how many civilizations survived nuclear war, right? How can we calculate that variable?
Right. It's very difficult because basically from the beginning of whenever you're capable of sending a signal that's capable of being observed by another species, from that point all the way until your destruction, that's how long you can communicate. And not only did you communicate that, but how fucking far is that away?
Yeah. Radio waves can't travel faster than the speed of light. So, so it's basically just an equation saying how likely is life in our galaxy with all these
I would say it's more than likely. I would say it's absolutely more than likely. I think that there's just a lot of arrogance to think that we're the only boys around. So
I agree. The earlier question that we had was, if we have a Goldilocks zone planet, do we assume that abiogenesis, if it happens on a Goldilocks planet, will result in humans every time?
Humans? That's ridiculous.
Right, exactly. It's very ridiculous.
Yeah,
that would be another arrogance of ours to think that we could anthropomorphize something like that.
Classic humans. Yeah, classic humans. What does God look like? Well, he looks like me.
And well, I mean that's the most amazing shit on the planet. I mean, we're not going to deviate from science, but that is what you just said.
No, we're staying on science. Yeah.
Yeah. What you said.
Well, the funny part's we're talking about astronomy and cosmology and all that, and that's what we're on. So we're still on the same.
True. Yeah, that cosmology is very.
Did you have a take, Scott or Coda?
I was going to say, what would determine a human? I don't know if you guys have heard this. So there's a family of people with.
Coda, I'll get back to you.
and it's been shown that it is a dominant gene. So anybody that has children with these people that have 6 fingers, their children are born with 6 fingers every time. Right. So like how many years does it take for all human beings to then have 6 fingers?
There's probably some.
Well, I mean, that's so there's so many variables. Like, what if they die in a car accident?
Let's
Yeah,
get Perry in here.
Well,
real
there's
quick.
there's surely some progression, some way we could falsify this, some progression of
Well,
increase of people with 6 fingers over time, right?
Well, I mean, like to me, it just seems that's the way evolution works, right? You have some sort of dominant gene that comes into being, and then it prevails, right?
Well, the
So
question was,
selected for
but
and not
what if
selected.
what if you run into somebody that has a counter gene of only having 4 fingers and it's more like dominant,
Exactly.
and then
Exactly.
it evolves into 5 fingers because one can't, like, one's more dominant than the other, but the other one's 6 fingers, so boom, 5 fingers.
Well, maybe in the future we only have 4 fingers, right? Like
I mean,
that's
sure.
That's not what I'm saying. Like I'm
No,
just
that's
the way
well, no, that's I was making a point not to.
genes
Oh,
progress.
so Scott, we're talking to people out here.
He knows that. Come on.
well, I thought the question was.
Yeah, I know we're not just in here talking.
I thought the question was, what makes a human?
Yes, exactly. So what makes a human? So like, what level of differentiation would be required for somebody to say this
Homogeneous.
is or is not a human? Like,
Okay, so I get what you're asking. Let's say
Homogeneous.
abiogenesis, Scott. Let's say abiogenesis happened on another planet, and
Yes.
the quote unquote humans that came about were like purple colored. You know what I mean? And then they had 6 toes, and they had right. But would it be humanoid?
I don't
Yeah,
think we're
yeah,
asking.
yeah,
I don't think we're asking a scientific question. I think we're
Yeah,
asking a normative
because I
question.
don't. Yeah,
Sure.
like Don's right here because
Yeah.
this is just a
You just
question
call
of
it
like
what
we're
we want to
calling
call it. Yeah.
yeah.
Sure.
Right.
I like to
think
throw
that
in weird stuff. Go ahead,
Yeah.
Coda.
I was just gonna say, yeah, I think the spirit of the theory is something more like humanoids on other planets, whether it's exactly human. If it was even human resembling, I think that would still be pretty surprising.
It might be our stubbornness again, wanting to call them humanoid and us human, because they'd probably call us humanoid and them human. Maybe they were here longer than we were, and
Yeah.
They would call us
I just wonder if
Slorbioids.
it could be a bipedal or quadrupedal system. I mean, it could be all kinds of
a
different.
featherless who was
Featherless, quadrupedal,
it?
fucking.
Who was it? Diogenes walked into Plato's school with a plucked chicken and said, "Behold, a man," because Plato called humans featherless bipedals or whatever.
Yeah.
Well, you know what I think? I think when we talk about what is human, I've said this before. I think, but it's just that which we include as like morally valuable or we care about it. This is why we say, "Oh, stop treating that dog inhumanely." Well, what are we treating inhumanely here? There's nothing human about this dog. But there is,
Anthropomorphizing it. Yeah.
which is
we do
fine.
that.
It's cool. I'm totally for it.
Yeah.
But people also anthropomorphize the planet. We do this as something that we do. So it's just things that we care about.
Yes, that's
so-
right. Gaia. A lot of people refer to or have in the past referred to the planet as Gaia.
Jupiter is
So
Jove.
aliens are going to be human insofar as we feel some sort of empathy, compassion. We're able to recognize ourselves in that.
Values. Yeah.
Yeah.
Yeah, I would agree. That's values. Even if you had a quadrupedal dinosaur come to you and say, I love humans, or they share our values in some way, we're going to work with them, I imagine. But that would be interesting.
Yeah.
No, I don't want to get too philosophical. We're good.
No, you can get philosophical. Go ahead.
So it was like, even though maybe even if we meet these things and they're like, we could go ahead and like concretely say these things are not human-like. Does it, given the capacity for communication at that point, when you have been able to integrate and decide whether or not these things are human-like, would they still, to you, have personhood? Now, like, because, you know what I mean, you literally had communication with them, you've interacted with them, you've decided that they're not human in the way that you are, like, they don't share those values that we were just talking about, but obviously they have some sort of at least perceivable semi-perceivable consciousness. Like we believe we could perceive consciousness from it. So it doesn't have personhood at that point because it's not human.
That would be a big question if we encountered a species on another planet.
That was different than us.
Yeah. What would we think about that? And our tendency to anthropomorphize is our infinite cognitive bias that will never go away. That's just the nature of being a human, is that we do anthropomorphize everything because that's the only frame of reference we have. Other than like if we were to think from a dog's point of view, which we can't do, it would be pretty interesting. But Coda, did you have something to say? I thought I heard you speak up there for a minute.
Oh yeah, I was just gonna say that I agreed with Don that the idea of other life on planets is kind of even humanoid feels pretty patently ridiculous to me. But I also feel like I want to suspend judgment because maybe someone has like a good argument for it that I just haven't heard. You know, I want to hear like the best version of like someone who thinks that. I don't know why though, but
I do too.
Well,
I want to hear a steelman of it.
Who was it that said man is the measure of all things? I mean, it's man who calls himself man. They measure an alien to be man. So that's
Yeah.
Well, think about a bunch of different there's so many different variables. Like think about a planet where it was more advantageous to have 4 legs because the gravity was stronger, and like whatever it was that developed like intelligence. Like there's so many variables to this when it comes to like what these life forms could possibly be. Like they also could just be like way stronger humanoids. That you know what I mean, like that had like better 2 legs than we did, like when it comes to gravity. But like there's so many different things. Like what if it was more nighttime than daytime? What if the sunlight was like there for 24 hours then gone for 36? Like what if there was some crazy shit happening on this planet that we couldn't account for evolutionarily from our standards of what it would take to do these things? It's
Then it'd just be different.
I guess I
different.
wonder.
Of course
like,
it would be. It
I
would
mean,
just be
that's-
different.
Well,
That was
that's not what makes a human, though, right?
No, I feel like we've gone. Okay. So I'm sorry. Maybe this is way more complicated of a thing to me, or to you guys, or from me. But a human is something within the Homo genus. That's literally like.
well, you're just begging the question: what do we call a homogeneous? Then?
Genus. Yeah. Like
The specific classification of people that are hominid from a certain era to another era. That's from that era to this era, like specifically with these with certain traits, and the traits that I'm talking about are like hominid traits that we understand.
So you
Like,
have a set amount of like axioms that it needs to hit before you call it
That's what-
something.
That's what I would call it, human.
Okay.
Like
And if
if
it's
somehow
missing-
evolution on another planet.
Yeah, but now we get into like Plato's. Is it Plato's elephant where he goes, remove the trunk, take off the ears,
right,
make
if one
it
of them
small.
is missing one
take
trait,
off
is
the
it not
tail.
a human? Like,
What if it?
exactly.
What if it misses 5 traits or 6 traits?
Well,
right?
hold on a second.
Trunkless, earless,
Neanderthals
small,
miss traits from
pink,
what we would consider
tailless,
on
light elephant.
what we consider on modern humans. Neanderthals had several different traits. So did other early hominids. They had several different kinds of
I'm
traits.
talking about like I call myself a human, but let's say I was disabled or just fucked up in some way, and I was missing one of those traits. Would you not call me a human?
I'd call you a human with a disability. Yeah.
So that's less than a human.
So it's not a human. It's something else.
No, it's a
something
human with
different.
the classification. Where did that come from?
But how is it?
It's literally a human with a classification.
But then it's not a human at that point. You can't call it
no, it
something.
is. It's a human variant, right?
No, it just means that the
Human with the
traits themselves are not what makes a human, is what
Yes, exactly.
they're trying to get at. The traits that you decide to make someone a human.
You can
Now,
say all you want.
This is where this is the difference between descriptive and normative, and we can't confuse the two. And I think that
Sounds like Jack's trying to be descriptive versus there's another camp of people trying to be normative about it and just calling it.
well, we're saying that you can't be descriptive of what is a human because it's not understood.
I agree.
That way.
I don't think you can have a certain set of axioms and traits that are the end all be all for some era of.
As soon as
because
the homogeneous happened, that's when
Well, it's useful. I agree for in science and whatnot, right? I mean,
Jesus fucking Christ.
this is what we do. We have these-
God damn
Thomas
it,
torture
dude.
time.
I'm sorry, Perry. I apologize. It just happened at the perfect time. I just got so pissed. Anyway, go ahead, Perry.
I don't know where I was going. I was trying to hold on to it, but I lost it.
I'm sorry.
So
Welcome back.
we were talking about the difference between descriptive and normative.
Yeah. And
Oh, yeah.
And I'm going through the and we don't think we can be descriptive with it.
Oh, right. That's what I was going to say. It's
Yeah.
a useful fiction, right? It's still normative and prescriptive at that point, at the base level, because, as whoever it was said, man is the measure of all things. We decide to call this era of beings humans or Neanderthals or Homo Cronin Magnans or whatever it's called, right?
Homosexuals, right?
Really?
Are
So
you calling me a monkey?
Yeah, I am. Go ahead.
I think we've lost the plot. We should
No,
keep
like
going.
I like where you're going, Perry, because people even use this notion of a Superman or an Ubermensch, right? So there's not just like people who are below man, but there are also people who are above man, but they're still man, right?
Yeah, no,
Yeah,
Hmm.
I mean that.
Let's let Perry respond real quick, Jack, and then
no, I agree.
you good.
If what you're saying is human used in the same way as animal is used, where there's different types of animals and different classifications, and there's different kinds of humans, that's fine. That's completely fine with me. Okay. I'm fine with that. I guess the point that I'm making is that it's still, even if we call it descriptive, is prescriptive at its first principle. This
Let's
is
put it
It's
this
it's
way.
hard not to argue that truth may be a normative concept.
Right.
It's an interesting
Let's just put it-
interesting question. Go ahead,
Let's put
Donna.
it this way. Everybody's here has seen Star Trek, right?
Yes.
For the most part.
Spock is not a human, right?
Half human.
see
Yeah,
this,
he's half human.
this is
That's exactly what
This
I'm
is what
talking
I'm-
about. Nobody watches that show and doesn't feel humanity and compassion and familialness towards Spock like towards any other human, right? So
he is human.
yeah, I would say that they're all human. They're humans who just look different
I
and
mean,
have
like-
different
like,
genetics and
you know,
different societies and different cultures.
even the
An
Cardassians would
extending
be considered
of the ego
humanoid.
of humanity is.
I
I
think
hear you.
this-
I hear you, Jack. But Scott said something funny.
Sorry.
Even the Kardashians would be considered human.
Yeah,
They
right.
look like lizards. Yeah.
Yeah, the Cardassians. Yeah, like
I
even
think
the
this answers our
Cardassians would be
question. I
considered
think that
human.
I think that we've completed the final stage of what it means to be human. Then, as the first question was,
Mm-hmm.
it is something that we could communicate with or feel some sort of, what did you call it, Don? What was the adjective? Feel compassion, I think is what you
Compassion,
said.
empathy,
Right.
see ourselves within them and see them reflect.
Well, see now
within us and vice
Jack's
versa.
shaking his head, and so what traits does Spock have, Jack? Or do you not think Spock is a human?
No, well, Spock is literally half human. I don't know what to tell you.
Right. So
Superman's human.
He's literally like 50% human, 50%, or whatever.
so
The
what traits is he missing any traits?
Yes,
There's-
on the human side and on the Vulcan side, he's missing traits. Yeah.
Missing? I don't think he's missing. I think he's just
On the side
different.
from the Vulcans, he's missing traits that Vulcans would generally experience. And on the human side, because of his Vulcan heritage, he's missing things that humans would generally experience. It took him a long time with these variables to connect to what humanity was. Most of what the original Star Trek was when he was with Kirk was like going through and going, oh, I realize that like in all of these things, the human part of me isn't something that I need to be worried about or like upset about, because the Vulcans had always told me that being human and having emotions was weak. The problem was that when he met the humans are like, oh, your Vulcan side and your pure logical side is so abrasive and we're not into it. He had a problem on both sides of this issue.
Yeah, but don't you understand that the parallel of saying Spock is not human flies in the face of everything Spock is supposed to be? A
Did I say
representation.
he wasn't human? At any point in that, did I say he was not human?
No,
He's
Jack,
not equally human to
Jack
other
called him
humans.
half human and half
Equally
Vulcan.
human to other humans, right? Because when we say human, we're not just saying descriptively things. We're saying things that, like, we have declarations of human rights. We have all these other things that go along with it, and those really do matter in our conception of human. It's more than just like a mathematical, scientific like description of the
I think
situation.
that's an extension of human ego, just like anything else. And it's an extension of you going, well, this Vulcan is so much like us. He's human. And so what if he wanted to identify with his Vulcan side? And you're like, well, I'm going to grant you. He's like, I don't want like whatever you think that the humanity is of this. I don't want to be involved with humanity. I want to be a Vulcan. I don't want to have
That's
whatever
fine.
you're extending to me. What I'm saying is that the extension of being like, oh, well, you're human too, is an extension of human ego, just like anything else is about.
Honorary Aryan.
You are also like us, so it's good. That's not.
No, that's
that's not.
that's what I'm saying. How human is used. That's how human is used. That's how we use it in our society. That's how we have developed
Yeah,
it,
but
right?
to other societies, when you embrace literally an entirely different world, not just a
Okay.
different, not just
So,
a different.
so
set of
Jack, so what am I
people,
saying? Like again, I'm not saying the descriptiveness. I'm not saying that Vulcans or Kryptonians aren't Kryptonian. What I'm trying to
Well, when you're saying you extend humanity, what like in the
Here,
same
I can help deflate
way,
this
in the same
normative
way
versus
they
descriptive.
they extend Kryptonian to you.
that's
No,
fine.
yeah,
Base.
What I'm saying is that may not be the same shit. It may
Okay.
not be
That's
the same
okay.
thing that you're talking
Let's
about.
just because
Let's
they
let Perry.
let's
Let's let
turn the
Perry jump
knob
in real
down
quick.
just a little bit.
yeah, good.
Real quick. I think I can help deflate this normative and descriptive thing that seems like we're talking past each other. The traits that we gave Homo genius, Jack, or Homo sapien, or Homo erectus, whatever it is.
Yeah.
Who came up with those traits and why? Or maybe why would be too difficult of a question, but
They were
Yeah, wise.
someone
classifying themselves.
who
What,
classifying
yeah.
themselves, right? Okay,
So how do
so is it ever changing, or is it more of a solidified set of traits for?
We will eventually evolve.
But even what about even for past eras? Could we change how we view the traits of what we call certain? We could say, oh, these people called these people Cronin Magnans, but it still seems there's this normative.
I think before Homo, there wasn't traits enough to interchange between us.
Hey, Don Don has something to say after this.
Was it? I don't think that. I don't
Oh,
think.
I'm sorry. I thought Don Don was.
Keep
I
going,
don't-
Jack. Please.
I don't think before Homo that there's enough
traits or enough of the same recognizability between the genus of what we would call humans to be the same as we are, even in like communication, understanding. I think that actually that's all. I don't need
But
to go.
who's calling it that? Who's calling it that?
We are later humans, the same part of Homo. Yeah, we evolved later and called it that.
So if so, that means that perhaps if a chimp evolved so much to some point where they had some introspection and they started calling themselves humans, they would also be humans.
Because they called themselves that.
Right.
But if they called themselves Pippadoos, they'd be Pippadoos. So I
Yes.
don't really see the point in like they calling themselves human part.
Well, I'm trying to find what the demarcation is of what makes a human a human. It's just that whatever object,
make it.
whatever subject calls themselves a human is a human, essentially.
Yeah.
Well, I would like to point out though that Homo goes back a long way. That it's like it's
No,
not
it does.
like
I'm talking about the beginning. I'm talking about the beginning of what our hominid ancestors were like, all the way till now, which is still in the same genus.
yeah, like Homo.
Yeah, no, very, very, very ape-like ancestor. Incredible. Yeah.
This is why I think that where we might be speaking past each other, that's a description. You're saying it's a category of human. You call that human. You leave that alone. When I'm talking about what makes something human and the way people use to denote what that is human, it's much more than just the category of science dealing with it. Which is, it's like, for example, we are all one. It's all in this together. We are all a part of the same group. To alienate people out of the human category, that's just what it is. Immigrants were alienated out of the human category. Blacks were alienated out of the human category for such a long time.
I just do a lot. I mean, do people that are in this room are relevant today like believe that?
Oh, there's a lot of bigots nowadays that I feel
I mean, in this room or like within our like circle here, like right now, that believe any of that.
But I'm not. But that's what no one's passing judgment on anyone. We're talking about the use of the word human historically and
talking about
society.
science.
It's
This
okay.
is science.
It's all right. Yeah, we're still on the term of astrobiology and what is it to be human, what is it to be not human from another planet. Yeah, we're still on topic.
Right. I think that maybe.
I know it sounds crazy, but we are.
Go ahead, Koba.
I think maybe a synthesis here exists where maybe there are traits by which we try to track what's human, but I think that those categories, they're kind of fluid, they're kind of fuzzy when you kind of test the
Very,
boundaries of them, like
yeah.
with the disability thing. And then also we have to understand, like, why did we come up with those traits to mean what a human is? And then it harkens back to sort of maybe the relation thing that Don Don's kind of talking about.
I think
So I
Jack,
think that these two
maybe-
views can kind of coexist in a sense.
I think
Yeah.
I think maybe the thing is that we've confused, like, for maybe my definitions and what's going on is when you're saying human or whatever to me, the way that you guys are describing it or using it is saying it sounds like personhood in my head, not human. And to give something personhood doesn't mean that it needs to be human or collectively understand or be similar to a human in any way, shape, or form. I can give something personhood that has nothing to do with being human, and it's not the same thing. Like an AI isn't a human, but if it became incredibly complex enough to where I couldn't tell the difference between it and another life form that could communicate with me and like convince me that it was biological, then I would just call it.
so human is more scientific for you, and then personhood is more like normative.
Yeah.
Okay. That's fine if you want to play that language
Maybe
game.
that's where we were talking past each other. Is I consider personhood
Yeah,
the
and
thing you're
th-
talking about.
But this
yeah.
is why I kept trying to reiterate the fact that we're talking about how people use the word human and
Mhm.
talking about it that way. Like, I like when they tell us, say, "Oh, don't stop treating that dog inhumanely."
They
It's
do
not
say
a
that.
human, right? It's not a human.
It's incorrect, but yeah.
No,
Stop treating them impersonhoodly.
right?
True. In person.
You could just say
Stop
you
being
could
so
say- you could say-
impersonable.
You could just say you're treating the dog improperly or you're abusing the dog. You don't have to describe anything else to it.
Well, there's the word inhuman, which is used in language which people hold
Right, which only
semantic
applies
value.
to humans.
no.
Really?
Well, this is the issue. You don't apply it in that way, but there are people, as Don said, we've heard this statement many times. Oh, the animals in the zoo are treated inhumanely, or we've heard something similar to that, where the way that they're playing the language game. I mean, you can say no to that, but it's. I mean, people.
I have heard people say that they
People do this all the
Well,
time.
sure.
animals in
But
human.
I'm just bringing up the difference of language. I'm not saying one's right or wrong. I'm not saying you're
No,
wrong in your use of this
I didn't
language.
say that.
Okay, well, you got real defensive and interrupted
No,
before
I
I
was-
finished my statement, so I figured perhaps there was some.
If that was the case, that I stay silent the entire time and then I express it with the same vigor, is there going to be like a problem in expression at that point, or is it just because I interrupted you?
Well, yeah, no, it's the fact that I can only get 12 words out usually, so I try to make them count.
Let's
All
do our best to. We're going to interrupt each other, and that's going to happen, and it's okay. But let's do our best to
Yeah,
keep it
sometimes.
as best we can to a minimum. Coda, did you have something to say? I didn't want to skim past you again.
I didn't have anything else to say.
Okay. Scott, you still here?
Scott left. Scott was like, "Fuck this."
And Scott was like,
Scott
out of
was
here.
like, fuck this
All right.
shit.
Well, okay. So
Fuck this shit,
we
dog.
talked about what a human is and what we would consider, what we would consider human or humanoid or whatever from another planet. So let's cover the rest of astronomy real quick. Who's yawning in here? Don't be yawning on my show, goddammit.
Don't be
Sorry.
on it.
All right, I'm just playing with you. All right, so we're talking about astronomy, right? And in astronomy are all these different branches, and that's what we're talking about. We talked about astrobiology. Perry made a funny comment, Don, that the study of future life on other planets is not something we should dump money into. We have enough problems here.
Not that much money. I
What do
think
you
it's worth some money, but not that much money.
What do you think about astrobiology in that sense, Don?
I mean, I don't know what would be like the economic utility of such studies. I'm sure all studies are important, so I'm always for funding studies. But yeah, we shouldn't dump the majority of our money into that. I think the majority of our money should be solving other issues that we're struggling with as a society.
Big time. So within let's talk about a few more of the fields. So you've got astrodynamics, which is the application of ballistics and celestial mechanics to practical problems concerning the motion of like rockets and other spacecraft. That's pretty simple. Then you've got a more complex field, which is called astrophysics. And we kind of talked about that a little bit. Let's explain what that is. Astrophysics is a science that employs the methods and principles of physics and chemistry in the study of astronomical objects and phenomena. Things like the orbits of planets and how they interact with each other. As one of the founders of the discipline, James Keeler said astrophysics, quote, seeks to ascertain the nature of the heavenly bodies rather than their positions or motions in space, what they are rather than where they are, end quote. So astronomy is the overall arcing term that we're using here. Astrophysics is underneath that. But astrophysics is not asking where something is in the universe, like a lot of people might think. It's asking about the actual, what they call, and what Newton called, celestial mechanics of the heavenly bodies. So, among the
What they
subjects,
are and how they operate, basically.
yeah,
Right?
exactly. So, among the subjects studied are the sun, other stars, galaxies themselves, extrasolar planets, exoplanets, interstellar mediums like dust and nebulas and all that kind of shit, cosmic microwave background radiation, emissions from
Cosmic
all this
TV
stuff.
dinners.
Yeah, emissions from all these objects are examined across all parts of the electromagnetic spectrum, and the properties examined include luminosity, density, temperature, and chemical composition. Because astrophysics is a very broad subject, astrophysicists apply concepts and methods from many disciplines of physics, including classical mechanics, quantum mechanics, thermodynamics, nuclear and particle physics, and molecular physics. So, in practice, modern astronomical research often involves a substantial amount of work in the realms of theoretical and observational physics. Some areas of study for astrophysics include the attempts to determine the properties of dark matter, dark energy, black holes, other celestial bodies that we don't know the ultimate origin of, the what's going to happen to the universe, things like that. That's what astrophysics is. Anybody here interested in astrophysics? Because I am.
Astrophysics
Oh, yeah.
is cool.
The one thing that I love about
There was an
astrophysics
eclipse.
is the sheer interdisciplinary scale of their experiments and their
Yeah.
research. It's just quite amazing how much of the sciences are used for that field. It's really not just physics, chemistry, engineering, everything works together to like get this research underway and done. It's a marvel of modern society.
It is. Astrophysics is one of the highest brow things that humans do. It's interesting. Like, if we want to go back to the initial founding of relativity and general relativity and special relativity, when Einstein figured out that the weirdness to Mercury's orbit was fucked up. When he figured that out, he almost had a heart attack, because it was his understanding in quantum mechanics of why that orbit was the way that it was astrophysically. And he solved that by understanding general and special relativity. And he was like, oh my fucking God, you know?
What's the phenomenon where Einstein accounts for why there was 4 images of the same thing?
Oh, Einstein's cross.
Einstein's cross. That's right.
Yep.
Okay.
Einstein's cross.
I didn't
Anybody
know that.
is interested in that, go look it up. It's not terribly hard to understand. Just go look it up. It's about objects and how they appear to us in space based on gravitational lensing,
The curving and whatnot.
yeah, the curving, that kind of stuff. Did anybody want to say something before I jump on a little bit?
No, keep
Yeah.
going.
We good.
Well, I'm glad you're enjoying the lesson, because that's what you're here for, everybody.
Oh, heck
Yeah.
yeah. I'm here to
Okay.
learn.
So we know what astrophysics are. Let's go to the next. We know what astrometry. It's the branch. Okay, I didn't know about this one. It's the branch of astronomy that involves precise measurements of the positions and movements of stars. Okay.
So while astrophysics deals with the things themselves and how they operate, like what they are, what they're made of,
Mm-hmm.
astrometrics, right?
Yeah, astrometry. Yeah,
Astrometry
astrometry. There you go.
Astrometry.
Is
measures where they are and where they're going.
Yes,
Okay.
positions
like,
and
like
movements.
cartography, but like for planets.
Yes,
I thought astronomy was where the stars were.
Astronomy studies the unit. Is anything studying the? Okay, so yes, you're right, because that's what we just read.
Yeah.
Astrophysics is studying the.
It's movement.
Let's read that again, because I think that was really interesting. Just that one part, that quote that James Keeler said. Quote, seeks to ascertain the nature of the heavenly bodies rather than their positions or motions in space. So astrometry is the sidekick to astrophysics. It's the one that's concerned with positions and momentums, and astrophysics is not caring about positions or motions. It's what they are rather than where they are.
So an
So-
astrometrist
Yeah, let's go back
is
and
is really useful for astrophysics, so they can know where to point their telescopes, how to track them,
yes,
stuff like
that's
that.
exactly the image that I'm finding right now. Is it's all about this
Okay.
the ways to position telescopes. That's interesting.
Okay. That's cool. I know. I always took that for granted. Right there's probably a researcher, a doctor whose job at the planetarium is to do that.
That's a hard one
Right.
to say, astrometry, and you're right, exactly what you just said, Don Don.
Okay.
The history of astrometry is linked to the history of star catalogs, which gave astronomers reference points for objects in the sky so they could track their movements.
Listening comprehension, 4th grade aced.
Oh, heck yeah.
Still has
This-
dyslexia.
Back to Hippocrates.
Oh, okay, Perry. Thanks, bro.
So I thought you said that in Newton's book it was the mechanics of the heavenly
Celestial
bodies.
Yeah.
Isn't mechanics entail movement
Yes.
and
Mechanical work is work. It's energy.
and astrometry is position and movement.
Yeah.
It's
Kind of what we're trying to figure out with particles and waves.
Okay.
Maybe it would be the difference between like how does a dolphin swim and the movement of the dolphin in the water, as opposed to the position and movement of dolphins in the sea.
Yeah. It seems as
Yeah,
though
like this-
astronomy and astronomy and
Astronomy and astrometry.
astronomy and astrometry are both extremely intertwined and almost the same thing, is what I'm seeing here. So
okay.
let's just go ahead and assume. But astronomy is the
Okay.
overarching category. But I'm just going to say astrometry because I can't pronounce it.
Right.
Astrometry.
Well, think of geometry, right?
Yeah, astrometry, geometry. Gotcha.
Trigonometry. that's-
Geometry.
I'm not
astrometry.
finding any big differences here between just standard. It says, apart from the fundamental function of providing astronomers with a reference frame to report their observations in, astrometry is also fundamental for fields like celestial mechanics, stellar dynamics, and galactic astronomy. So, yeah, it's part of the study of astronomy, and it's pretty much the same thing from what I can tell. So next one is cosmology, and this one is a very important one. This one is just as
Cosmology.
important as astrophysics.
This is like the makeup, right?
This is the makeup. This is the origins, right? So cosmology. It means world, right? And logia is the study of. So it's the study of everything that is. Cosmology is a branch of physics and metaphysics dealing with the nature of the universe. The term cosmology was first used in English in 1656 in Thomas Blount's Glossographia, and in 1731 taken up in Latin by German philosopher Christian Wolff.
Wait, the word cosmology was first used then?
Yeah, in 1656. That's interesting.
Because in ancient Greece they used cosmos, like cosmos.
Yeah,
polis.
that was the world. Yeah, it meant the
Right.
the world or the universe. Yeah. Religious or mythological cosmology is a body of beliefs based on mythological, religious, and esoteric literature and traditions of creation myths and eschatologies. In the science of astronomy, cosmology is concerned with the study of the chronology of the universe, the time frame. So that's what we're really looking at when we're looking at cosmology, is the time frame from Big Bang to heat death or whatever it may be. I'm still very skeptical about heat death because we don't know everything about physics, and we certainly don't know everything about thermodynamics. And I don't think the universe is a closed system, so therefore entropy may not even be a problem. I don't know. I'm not a theoretical physicist, but that's just my take on it.
Entropy is another useful fiction.
Yeah. What do you think? Anybody?
Eternal.
Go
What I
ahead.
think about that.
Eternal, yeah. I don't see any reason that it wouldn't be a closed system, but I don't. That's
You and I have had that conversation a lot. Is how can we know that a universe, since we only have one to compare to, that a universe is a closed system? That seems highly presumptuous. So
It's very. I mean, like just in the same way of any other possibility, it's very capable of being an open system. The only reason why I generally tend to see it as a closed system is because when we talk about the expansion, and but the expansion of the universe itself is expanding, but it's not expanding into anything as far as
most physicists are aware of or like want to talk about. So if it's not expanding into something, I don't think that there's something outside of it that it would be capable of making it a non-closed system, because it itself is expanding and it's not expanding.
Maybe the edge of the universe, quote unquote, is infinitely far away now.
Well, it will be essentially.
The further stuff gets away from us, the further it's accelerating
that's
away.
interesting.
Yeah.
Maybe the boundary is the fastest accelerating thing, and there is a closed system, but it's all practical. All things practically speaking, it's an open system because the boundary just keeps going farther and farther away from us and whatever.
Yeah. And it's accelerating the further we get closer to whatever we might consider that boundary. It may just be more and more stars.
I wonder.
I mean, what if you got to a point where the galaxies were so far away, it seemed as though there were nothing after that point, and you demarcated that as the edge of the universe?
Right.
But there's actually still stuff.
For all intents and purposes, that might as well be the edge of the universe. But there's shit way out there expanding so fast that light can never reach it.
What, Coda?
The idea of an expansion from a point, to me, if we were to even talk, like, I agree that that would totally happen. The demarcation would be just, this is the edge of the universe because of the distance. But we're talking about the expansion from a point all the way out from a closed system. If it's the only thing that would be interesting to me is if the inside of that closed system, because of the size and because of the distance, it's moving away from all of each other, that quote unquote systems started forming inside of this closed, ever expanding system that started acting or interacting differently than the main system that it's a part of.
Like localized, you're saying?
Yeah. They would end up with, it would be everything, the main closed system would be so spread apart that there would be other systems inside of other closed, smaller systems inside of it.
Hey, Coda, can you try talking real quick? I can't hear you for some reason. Did you say something a minute ago?
Hello.
Oh, no.
I can't hear him, guys. Can y'all hear him?
Yeah.
Okay.
Oh,
did you have anything? Since I can't hear you, just go ahead and say anything if you had something to say.
Oh, yeah. I was going to say that's a cool thought. It's imaginable that we think we found the close of the system, and we go, here's the last thing. But in reality, there's something far beyond what we could ever reach, maybe like shooting away from us, like at a speed that we could never catch up with.
It remains
I find that idea really interesting.
Remains metaphysical for that reason.
And that's the only way that seems viable for travel, at least from my perspective at this point, when it comes to like far intergalactic or interstellar, universe, like whatever travel, is to not actually travel, but to bend space. Because if we can figure out the secrets of bending or folding space, the distance that is incurred from things would only be able to be matched by us arriving and the expansion of the universe continuing on at the incredibly rapid rate that it would be going on, and then us arriving at what we would have understood as the edge of the universe to only fail and have the edge of the universe continue on.
Yeah.
Yeah. I don't want to interrupt anybody because I can't hear Coda. That sucks. I don't know what the deal is.
Ah, rip.
Stupid
Yeah,
ass.
I don't know. It seems to me that, yeah, it's interesting. Be real interesting if there was, like, an end. Yeah.
What would that entail for you if there was an end versus an assumption?
I don't even know, right?
Yeah.
It's hard for me to tell what the end of a thing is other than the boundary between two things.
True.
Yeah.
I mean, I guess.
Well,
Yeah.
experience ends, right? I'm
I was
pretty sure
gonna
if they
say
shoot
death.
you in the face,
Yeah.
like your experience ends.
But is that a boundary between two things?
No, I don't think it's a boundary between two things.
Could be an
because-
afterlife, you fucking atheist Jew.
I'm still open to an afterlife, but
Hey,
yeah,
if there's an afterlife, then you know something.
it'll be a bonus.
It would be a bonus. But until then,
Yeah.
I'm pretty sure if they shoot you in the face, it ends.
I mean,
Unless you're going down.
I mean, there is a response here, but it's getting very metaphysical. Maybe I shouldn't bring it there.
Like, is it you know what? If my heart's heavier than a feather, they'll have to get over it. Okay.
Oh,
Yeah, and now I start existentially thinking about the fact that I'm going to die one day and how I'm not ready to do that. And
Right.
yeah, thanks,
I
thanks
face that.
conversation.
I
Thanks
think about that.
conversation. I appreciate
something-
this.
Even
It's something that I
appreciate
get into
this,
so
thanks.
much that
Hey, death
My
is going to be brought up a
existential
lot on.
nihilism.
death and nihilism are going to be brought up a lot of my shows because I think about that shit a lot. So it's okay. Don's like, no, fuck that shit.
Even if, yeah.
Positive shit right now. Okay, so we talked about so let's talk a little bit more about cosmology.
I think that's why so many people believe in religion, is because they're scared existentially of their death and they want there to be an afterlife.
That's a lot of it.
Yeah.
I will say, yeah, sure.
Well, Coda?
Oh, it's whatever. Don't worry about it.
Silly Billy.
That conversation could go on forever.
Silly
I just want to
Billy.
hear about science. Heck
Yeah,
yeah.
that's a later conversation. Science.
Science.
So who wants to know how volcanoes do? No, I'm just playing.
No, I'm gonna keep going. I just didn't want I can't hear Coda talking, so I don't want to
Everyone take a metal
Oh,
mesh. It's
you can let
cardboard,
him know that I'm
wet
done.
it, put it over the metal mesh. Now I'm so yellow, it's unbelievable. The amount of
Yeah,
yellow.
you got some sepia
Wow,
color.
man.
Coda, if you start talking, I'll say something as a
Okay.
mediator, so Thomas knows.
Thank
True, yeah.
Oh shit! Yeah. Wait,
As he gets progressively more yellow, he gets progressively more in Mexico.
I don't know why. All the color was so perfect beforehand, and I decided to like.
Now it's vomiting. It's vomiting a fucking plethora of colors on you.
Is it hold on, Perry, can you hear Coda too?
I could hear Coda, yeah.
Okay, me and you can hear Coda, but Don and Thomas.
Oh, I can hear Coda. I hear Coda.
Oh,
Yeah, it's because I
Yeah,
disconnected
yeah,
earlier, and I probably need to
right.
rejoin the.
Okay.
For some reason.
back. Let's put Thomas here. Let's put me
Can I do
here.
that? Can I leave and rejoin under that same link, or would it kick me out, Perry?
No,
you
yeah,
can do
yeah, you can do that.
All right, let me try it real quick.
All right.
Nice.
Oh man.
Okay, my color's back to normal. Everything is good. The day is saved.
All right, time to take over Thomas.
Was there
Heck yeah.
something wrong with your other complexion or?
I don't know. My camera just disconnected and
We didn't
reconnected.
like looking Asian.
Thomas leaves, we're all like, fuck that guy.
Technically, I am Asian though. Technically, I am.
True.
Oh.
I was born in West Asia.
Coda, try talking.
Yeah, try
Hello,
talking.
hello,
Coda.
hello, hello, hello.
Oh, I got you. Sweet. All right.
OMG.
Yes.
Internet trouble. Ba-da-ba-ba-ba.
Bum, 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 bum.
So
And everybody's back.
let's talk a bit more about cosmology. Let's learn how that started, because I think cosmology is going to be one of our most important sciences to cover, especially within metaphysics and all that shit. I think it's very important in terms of physics. So astrophysics, physical cosmology was shaped through both mathematics and observation in an analysis of the whole universe. The universe is generally understood to have begun with the Big Bang, which we can explain and expound upon that further, but I'm just going to assume that our audience knows what the Big Bang is, or the Big Expansion, followed almost instantaneously by cosmic inflation, an expansion of space from which the universe is thought to have emerged 13.799 billion years ago. Cosmogony studies the origin of the universe, and cosmography maps the features of the universe. So it's further, physical cosmology is further divided into those two studies. Cosmogony studies the origin of the universe, so that's what we're talking about when we talk about the Big Bang, and cosmography maps the features of the universe as it evolves over time. So I don't know. Let's see, it says discoveries. Physical cosmology is the branch of... Okay, we know that. Don't tell us that again.
True.
It also includes the study of the nature of the universe on a large scale. In the earliest form, it was known as celestial mechanics, to study the heavens. Greek philosophers Aristarchus of Samos, Aristotle, and Ptolemy proposed different cosmological theories. The geocentric Ptolemaic system was a prevailing theory until the 16th century, when Nicholas Copernicus and subsequently Johannes Kepler and Galileo Galilei proposed a heliocentric system. This is one of the most famous examples of epistemological rupture in physical cosmology, where they had a brand new idea of what the universe was. I mean, it was so life-changing. It was so world-changing that they put the dude on house arrest for what, like 4 years or something? I can't remember. It was a long time. Anybody know
They
that?
put him on parole.
Yeah. So Isaac, and this is all for the audience because I want them to learn about this stuff too. Isaac Newton's Principia Mathematica, published in 1687. I mean, this dude went into a cave while I think an outbreak of a flu was going on, and he sequestered himself in a cave and he wrote the Principia Mathematica, and it was the first description of the laws of universal gravitation and the foundations of calculus. It provided a physical mechanism for Kepler's laws, and also allowed the anomalies in previous systems caused by gravitational interaction between planets to be resolved. A fundamental difference between Newton's cosmology and those preceding it was the... Go ahead.
No, sorry, I was just talking to Scott.
Oh, okay. So it was a crucial thing. It was a big deal when Galileo and Copernicus did their things. Modern scientific cosmology is widely considered to have begun in 1917 with Einstein's publication of his final modification on general relativity. In his paper, Cosmological Considerations of the General Theory of Relativity. General relativity prompted cosmogonists such as Wilhelm Sitter, Carl Schwarzschild, and Arthur Eddington to explore its astronomical ramifications, which enhanced the ability of astronomers to study very distant objects. This is what relativity gave us. Physicists began changing the assumption that the universe was static and unchanging around this time. 1917, 1920. In 1922, Alexander Friedman introduced the idea of an expanding universe that contained moving matter. So these things evolved. I knew I wanted to talk a lot about cosmology because this is the beginnings in cosmogony. These are the beginnings of our universe, and there's a whole section here on religious and mythological cosmology. And I don't see how that can be useful to us whatsoever. Does anybody have a different opinion?
It's useful for us insofar as it teaches us about our proclivities.
Okay.
But I think in a modern context, we're just at the next stage of that same type of thought,
Mm-hmm.
right?
I mean, that makes sense to me.
But I wonder what solutions did Einstein's theory of relativity really give the scientific community that allowed it to rebirth a new form of cosmology? I actually don't understand what exactly happened there.
Well, we always thought that the universe was static and that there was no like fabric of space-time. But when we learned about relativity in general and special relativity, we learned through special relativity that mass and energy are the same thing. They're interchangeable. They're properties of each other. And then we also learned in general relativity that space bends through gravity, and then matter follows that space curvature. And until that point, we didn't have a cosmology that would help us to understand that specificity.
Okay, and now the cosmology can help us in aiding in
Yes.
developing a
Relativity
notion of
makes
where
a
else to
lot
look.
Yes, exactly. Relativity makes a lot of predictions possible that were not possible in the late 1800s with like the early quantum mechanical field theories and shit like that. They didn't even have quantum electrodynamics or quantum field theory until the mid 50s, I think, or something like that, somewhere around Feynman. But yeah, I mean, if we didn't have relativity, we would not look at space the same way. We would look at it completely differently.
And
So I think it was a huge. I'm sorry.
It's something engineers actually use all the time as well.
Right.
Engineers understand relativity when they're like understanding. I'm going to a satellite, so I have to calculate these like minute time differences that are going to take place between here and there. These are
no doubt,
very important.
Did you have something to say, Don?
Nope.
Okay. Let's go a little bit further. So we did change on that. Let's see. Since around 1990, several dramatic advances in observational cosmology have transformed cosmology from a largely speculative science into a predictive science with precise agreement between theory and observation, which is what we want. These advances include observations of the microwave
background
radiation from the COBE and Planck satellites. Large new galaxy redshift surveys, including something I can't pronounce, and SDDS, observations of distant supernova and gravitational lensing. These observations match the predictions of the cosmic inflation theory, a modified Big Bang theory, and the specific version known as the Lambda CDM model. This has led many to refer to modern times as the golden age of cosmology. So today, I guess we're in the golden age of cosmology. Let's see what Lambda CDM is. So the Lambda CDM model is a parameterization of the Big Bang cosmological model in which the universe contains three major components. First, a cosmological constant denoted by a lambda Greek symbol associated with dark energy. Second, the postulated cold dark matter, which is CDM. And third, ordinary matter. So that is our makeup right now. That is our cosmological model.
Interesting.
Yeah, the Lambda CDM model.
That's so strange. I'm getting deja vu from that idea.
Go ahead.
You know what's really wild?
What?
Have you seen the stuff from the James Webb Telescope where they're seeing like formations of galaxies way longer back than they should possibly be seeing these formations of galaxies?
Mm-hmm.
Yeah.
Oh, yeah.
To me, I look at that stuff and I get excited.
Oh, this is interesting. On Wikipedia, they have, oh my God, they have historical cosmologies. So like, yeah, so like they have it set out here to where like Hindu cosmology, author and date, the Rig Veda, 1700 to 1100 BCE. The classification of their cosmology is cyclical or oscillating and infinite in time. So primal matter remains manifest for 311 trillion years and unmanifest for an equal length. The universe remains manifest for 4.32 billion years and unmanifest for another equal length. Innumerable universes exist simultaneously in the Hindu cosmology, and these cycles have and will last forever, driven by desires. So that's their cosmology, and it gives me like the Jainist cosmology, the Babylonian cosmology, the oh my God, biblical cosmology, Earth floating in an infinite waters of chaos or in the firmament. You know what I mean? The outer chaos ocean. That was their cosmology, the ancient Jews. You want to expand on that, Don? You know anything about how they thought about cosmology in the Jewish Bible?
Well, it depends who you ask, when you ask, and at what point throughout history you ask them. But the
Sure.
prevailing like idea is that it was pretty literal. They thought that this was how things worked, because they kind of had a very like matter of fact. Oh, this is how nature works. This is how God works. These are how we understand and justify the ways in which our society deals with laws. And why? Because God is the creator of the universe. He did it for 4 days. Speech is that which creates. But this is really how they thought about the world. I know
And this is the problem. Yeah.
in a specific book, a rabbi, what's his name? I think it's Rabbi Yochananov.
Sure.
I could be wrong. Whatever.
Oh, I'll remember that and search it up later to falsify you because I can spell that.
I have a book about it. I don't remember what the name is, but there was a rabbi who said, if it's true that the earth that the sun goes around, that the earth goes around the sun, the whole Torah is false. Well, modern rabbis will say, well, it doesn't make that claim, right? So I would say originally was very literal, but as time.
Yeah, and the funny thing we know about Genesis is that the order of events of creation in Genesis do not match up with the order of events and how we have seen it in cosmogony, especially with the Lambda CDM model. Does not match up at all with that, you know?
No.
Do you think any cosmology besides that would ever even got into dark matter and dark energy? I just don't see it as a possibility because they didn't have telescopes and all the shit that we have.
These societies didn't even have the concept of zero. So
no.
let's
no, you're right.
They didn't even have the concept of zero. So they couldn't even start beginning and thinking of the world through negatives like that, or like yet to be's or whatever, or like the negations of. They couldn't even think of things that way.
I may have an issue with that statement or question. Would they have even gotten to dark matter? We did get to dark matter because of the way that things were. It was the silliness of the Jews and the Egyptians and the intellectualness of the pre-Socratics, and then Descartes. I mean, what does Don say? Like, if things were different, they'd be different.
Yeah.
I mean, all of these things played a role, I would say. Even the silliness of all of the crazy shit firmament and all of this stuff.
They did get there, I guess. We are them getting there in the future
Yeah.
in
Yeah.
many respects.
Right, exactly.
Sure.
But if we just say without modern advancements like relativity, would we get there? No, of course not.
Without modern relativity, would we? No, well, chronologically, in this monistic universe, it seems as though it was a necessity. We needed to get to relativity to get to where we are now. Yeah, we guess
Yeah.
we needed that. Yeah,
It
might
is
be
where, yeah.
confusing language.
I think
don't know.
Thomas and I are more speaking to the fundamentalist viewer or someone who
Mhm.
thinks that you can find answers about the universe by appealing to the text specifically.
Mhm.
You know, to you out there, join the party. The texts are great. They have tons to say. They're our history of what we thought about the world, but now we have new thoughts that
Yeah.
give us more utility and ability to make sense of the world.
Yeah.
But God.
But God.
But God.
But one time I drove and I felt like God spoke to me and I got saved, but I didn't get killed by a deer. God's real. Next.
That was it. That was the
I
moment
missed the
that
deer
I
by a half inch. It was God. Oh my
True.
God.
any coincidence apparently is God.
All unknowns and all coincidences are God.
God.
Yes.
Yeah, God of the gap.
True.
Let's talk. This is so interesting on this Wikipedia page on cosmology, guys. It gives me like let's talk about so the Platonic universe. It was geocentric. It was complex cosmogony, finite, extant, implied finite time, and cyclical. Static Earth at center, surrounded by heavenly bodies which move in perfect circles, arranged by the will of a demiurge, in order. Moon, sun, planets, and fixed stars, complex motions repeat every perfect year. So that was the Platonic universe, what Plato thought about as cosmology. And then it goes into, does anybody know Eudoxus of Cnidus?
No.
Eudoxus of Cnidus? Okay. 340 BCE, and later Callippus also said this, geocentric, first geometric mathematical model. The heavenly bodies move as if they were attached to a number of Earth-centered concentrical invisible spheres, every one of them rotating around its own and different axis at different paces. There are 27 homocentric spheres, with each sphere explaining a type of observable motion. So this was what he did, and then Aristotle took this view, but he had a static and spherical Earth, and it's surrounded by 43 to 55 concentric celestial spheres, which are material and crystalline. The universe exists unchanged throughout eternity, contains a fifth element called ether, that was added to the four classical elements that Aristotle thought the world was made of. That's just interesting that we came from that. You know, people just intuiting these things from the ground, looking up there with no mathematics.
So asking, would the Jews get to dark matter? Yes, perhaps they would, just as we got there with the static crystalline Aristotelian universe and Platonic universe.
Exactly. What I'm looking at here is they have two cyclic. In 1983, there was so cosmic inflation in 1980 by Alan Guth. That's the Big Bang modified to solve horizon and flatness problems. Based on the concept of hot inflation, the universe is viewed as a multiple quantum flux, hence its bubble-like nature. Other universes are formed from other bubbles. Ongoing cosmic expansion kept the bubbles separated and moving apart. That's interesting. So these are some of the new ones. There's also eternal inflation. It's a multiverse based on the concept of cold inflation, in which inflationary events occur at random, each with independent initial conditions. Some expand into bubble universes, supposedly like our entire cosmos, and others don't. Bubbles nucleate in a space-time foam.
It's not a bad metaphysical assumption to work with. What year was this? Was this around 1980?
1983. Andre Linde. Big Bang with cosmic inflation.
Okay.
So everybody's just building on it. And then they've got a cyclical model in 2007 as one of the last ones here. And I don't know what phantom dark energy is, but apparently it's a hypothetical form of dark energy satisfying a certain equation for negative kinetic energy. I don't know what exactly that means, but it says It's a solution to Tolman's entropy problem. Phantom dark energy fragments our universe into large numbers of disconnected patches. Our patch contracts containing only dark energy with zero entropy. So that's
I want
Yeah.
to mention something that I've been thinking of lately. It's
yeah. Go ahead.
how objective math is, how real, how good is it?
Well, it's a
Those are
deduct.
3 different questions, right?
Well, these are just similar things that I'm thinking of for what I'm about to say here. For example, we have these notions of the phantom dark energy, as you just described to us,
Mhm.
in order to satisfy an equation, some other equation. It's like, oh, the math is infallible. Now we need to have our empirical observations be match with it,
Comport to the
right?
math.
So we have to comport to the math. And I'm wondering
Yeah.
if we're putting so much
Right.
reliance on either math or the specific equation as if it's infallible.
Right. Why shouldn't the math comport to the observations?
Exactly.
Yeah.
Yes,
Exactly.
I agree with that. I agree with
And
that.
there's
Yeah.
also, I don't know if anyone knows anything about approximating, but there's these YouTube videos. I saw someone post in the meme section on Discord. This guy approximates 1 + 2, right? And after hours of math sped up, of course, and just these long equations, you end up getting 3.0017.
Mm.
You don't end up getting 3. You end up getting, and
Mhm.
that bothers me. Again, it's perhaps the whole point of approximating, which I don't know much about, if that is entailed where it has to be like that, but it's not 3.00000. It's
Mm.
3.00017. Whatever it was, and that worries me. I guess if like
Right.
Expand on that.
Yeah. I mean, this question instantly plunges you into metaphysics, right?
Yeah, there's no problem with that. We can jump between
just
meta.
how reliable is math, and I just wanted to mention
Well, let's ask
that,
that question. I mean, how reliable is a deductive system that we made up?
right?
Even though it describes what is going on in the universe, what is actually happening, we made up the numbers and the sequences like addition and stuff that we use within them. It's the fact that it is a deductive system. We have constructed it as such, as a species. And remember, I've always said, you may disagree with me on this, but I think that humans naturally intuit geometry, and from geometry we get the mathematical standards that we adhere to. And so I don't know how to explain that any better, and maybe I'm being woo-woo when I say this, but I think we can intuit, since we are nature, we can intuit mathematics from that, the patterns in reality that exist. We see those, and then we make connections between those, and then we get math and geometry and math from that.
Yeah.
I agree. I agree. I think we intuit it. My whole stance on math is that it's actually empirical, and then we induce, and then we deduce after that.
Yeah.
I've mentioned once before the speed of light. It's like, is it exactly 300 kilometers per second or miles per second? Or whatever? No,
186,000 miles per second. Yeah.
right. And that seems to be like such a perfect. Like, that's weird. Same thing with
That's us probably not understanding the exact speed. That's probably an approximation.
okay, good.
I imagine that they cut that off as an approximation.
So same thing with gravity, though. Is it 9.8 meters per second per second? Is
Ooh,
it
that's a good
exactly?
question. I don't
or
know.
is it 9.800340025?
It's probably rounded off. If knowing scientists and the way that they like to make things practical, it's probably
Okay.
rounded off.
Fair enough.
But we can ask. I need to have a mathematician on the show so I can ask him. Hey, is it actually 9.8 meters per second squared, or is it like 9.87526 or something like that?
Can we just look that up?
Yeah, I
look
want
it up. Coda,
Oh yeah,
go ahead.
so math is like a tautology, right? Like things which are mathematically true or like deductively true. Although it is a system which we have to kind of equivocate to reality at a certain point in order to apply it as deduction. But that's the true with all conceptual analysis and prediction, right?
Mhm.
If you were to go wrong and if math were to be wrong and it wasn't in the application of the conceptualization
Math
phase.
has been wrong many times, Coda. Math has had to been redone. They had to redo set theory in the late 1800s because of Russell's paradox. Set
Oh,
zero.
So
sure, yeah.
the speed of light exactly is 299,792,458 meters per second.
Good. So even that, like, there's probably some decimals next to that.
Yeah, probably, but they just become negligible, I guess.
And that was speed of light, you said. And then here's gravity. It says about. It says the word about 9.8 meters per second per second. So I don't know if I'm gonna get exact. Oh, here's one saying 9.81. I think I knew that from physics class, but still. Anyway, my point is, wouldn't it be perhaps an infinite number of decimals behind the value, or is it stop? Does it stop at the 10,000th decimal place? Like
I guess it just matters to where they have like where rounding works and where it doesn't. Sometimes
like I'm
rounding-
talking capital T.
It
truth.
matters to where measurement is relevant.
But Perry, capital T truth is as much.
So
of a-
Jack, you're saying like the sig figs, like they stop at a certain point just because there's no point to keep going.
No. It stops for us at a certain point. It's essentially infinite.
Oh yeah, well we'll die before we finish the
The
infinite.
difference is like if I'm trying to hit a baseball 30 feet and I need it to land exactly at 30 feet, if it lands at 30 feet, 0.0000007.89253, it's not relevant at that point anymore.
Right.
Just because it's not exactly on 30 feet, it's so negligible of a decimal point to us at the point of measurement that it becomes non-relevant to what we're doing.
I mean, all quantum calculations that they're going to do in any theoretical math or any mathematics is going to be like 14 decimals accurate, and then after that, it's going to be negligibleness. You know what I mean?
That's where my suspicion from math comes from. Then perhaps is that we just stop due to approximating sig figs, whatever. We just don't need to go on that far.
Yeah, math isn't perfect. Even though it's a deductive system, it isn't perfect because they've had to redo it a lot of times. So the reason why English isn't deductive is because we play with the meanings of things. You can't play with the meaning of the number one unless you want to be ridiculous, I guess you could.
I guess there's like these physicists that look at the world in numbers, right? They see a car driving by and they put how much it weighs and how fast it's going. The numbers that they're putting there are not the true numbers, though. The true numbers are going to be an infinite long.
Yeah, they're all going to be
constant.
non-repeating, non-terminating decimals.
Right.
Because that's
Changing,
the nature of like the
yeah.
randomness of the quantum realm. Remember, you and me the other day looked that up, that quantum indeterminacy does have randomness. So at least as far as we understand it now, it may be an order that we can't calculate.
Yeah, it goes from A to B to C to D to A to C to A to C to A to B to C, right?
That doesn't mean that there isn't an order that we can't find there. It just means so far that's random to us.
Right.
So,
right.
I don't know. I forgot what I was going to say. Go ahead, guys.
No, I guess that's the Platonic in me is thinking of what the true value is, not the 9.81.
Mm-hmm.
I want the 9.8100254.
Yeah.
Dot.
Yeah. I think that's the wrong way to think about what the trueness of things are. We're not. I don't think we're going to be able to describe it with mathematics.
Yeah, no, I'm not making that. I'm not making that case. I'm just trying to put us in a headspace where we can think of the noumena, so to speak.
Mm-hmm.
Okay,
Right?
that's fair.
Yeah, and I get, it's not special in science. There's a reason why the natural sciences use empiricism and the phenomena. It's not the noumena, which may be attached to formal sciences with logic and math, maybe, but.
I don't even know if the formal sciences would get us to noumena because that's just all abstract. Everything that's a formal science is just a priori,
Yeah, and again, my whole thing is that a priori things actually come after experience. So,
I agree. It's. I don't know if you have one without the other. I don't think that is possible.
So I get that, but just trying to help us transcend to a mentality of an Ubermensch, perhaps, or a eternal geometer. Or an earthly omniscient being,
geometer. The moral calculator,
an earthly omniscient being.
Well, I think I've. Is everybody getting tired? Because we've covered a lot tonight.
I'm tired.
Yeah,
Nice.
I'm good.
I'm
I
a little
figured-
tired.
Getting extraterrestrial.
Oh shit. Okay, well guys, we're gonna go ahead and wrap it up here so that Perry can get some rest and Don can get some rest.
Everyone else said that they were tired except me. Anyway,
Oh, did you? I thought you
No.
said you were tired, Perry. My bad. I'm
I
sorry.
said I'm good.
Anyway, it's been an hour and 45 minutes, guys. I really appreciate you coming and hanging out. Please subscribe to my channel, Thomas Panner, at Pangburn Universe, and Don Prager at the Pangburn Universe as well, please. Go to Pangburn at YouTube, and in the top
Don't forget
right...
about Jack.
Yeah. Yeah.
It's all right. My presence will become greater later.
On the Pangburn YouTube, guys, in the top right corner, you'll see our Discord link, and you can come and hang out there with us and talk to us. So please come and hang out and be a part of our community with us. We love doing this stuff. Thank you guys for the hour and 45 minutes of your time, and we love you. Peace out.
Later.
Peace.